Alright guys, today we're going to be talking about complex numbers, also called complex imaginary numbers. So we can add here imaginary. So let me, this does not let me very well. Let's see. Or imaginary complex number. I'm not sure which one comes first. There it is. Alright guys, so if you remember from yesterday, I to the first power, or just regular I, represents the square root of -1. And then if we square root the square root of a -1, if we square, the square root of -1, pretty much the square and the square root cancel each other out, giving me only -1. So I squared is just -1. Well, what about I to the third power? Well, that means that I would have square root of -1 times itself 3 times, right? So we know this is I squared, or I times itself twice. Pretty much the square root cancels each other out, which is giving me -1. And if I multiply times another square root of -1, that's just going to be negative square root of 1, or negative I. I'm not sure if I make it more complicated by showing it like that. So let's make it look like this. We know that I squared is -1 times another I would be I to the third, right? So I to the third power, which is already over here, is negative I. Well, if I multiply that negative I times another I, then that would be I squared. So negative I squared, which we know that the negative I squared, right? Sorry, let me put over here, negative I to the power of 2 would be negative of a -1. So then that would be a +1. Okay, and then another way of seeing that, if you have I to the 4th power, well, that means that you have I squared times I squared, right? You would add the exponent, so that's I to the 4th. Well, we know that I squared is -1, and then another -1, so that's how we end up with +1. And after that, it all starts repeating again. So we only really need the first 4, and then it just becomes a pattern. So I to the 5th power would give me square root of -1. I to the 6th power would go on and give me a -1, and so on. Now, the reason why we need to know this is because we're going to go into more complex expressions here, or problems. So one thing we need to know is the standard form of complex numbers is this, where A is a real number and B, I, would be the imaginary part. All right, so our first example from yesterday, okay, if we have a negative number inside the square root, can I make spaces here? I feel like this is going to be too crowded. Okay, so from yesterday, we're going to have that square root of negative. When we have a negative inside, you want to separate that from the 9, so we can actually square root it. So we're going to split that into -1 times 9. And then the rules of radicals means that I can separate them, since they're multiplying, into its own radical. And then we know that the square root of 9 is 3, and that the square root of a -1 is represented by I, right? This part right here. So that is our answer, 3I. Okay, that's just a review of yesterday. Now, check this one out. So we have 3I, that means we have 3 to the square root of -1. But right now, when you have 3I plus 3I, think of it as when we have a variable. If we had 3x plus 3x, we would end up getting 6x, right? So this is the same as 6. Okay, so when you add, as long as they both have an I, we can add them. If they don't both have an I, then we couldn't, and we would stop right there. Right, example 3. In example 3, we're actually multiplying. So you multiply the number times the number. So that's going to be 9. And then I times I is going to be I to the power of 2, or I squared. Now, when we have I squared, we're going to go back up here and we remember that I squared equals -1. So then this is the same as 9 times -1. So that's going to give me -9, excuse me. 9 times -1 is -9. Okay, so make sure you have your notes with you so you can go back and check these problems out so you don't forget how they work. All right, this next part, we have 3i times 5. That's just going to be 15i, just like if it was a variable. Then 3i times 5i. So we multiply the numbers. 3 times 5 is 15. And then we multiply the i's. I times I is I squared, or I to the power of 2. And we know that that's going to be a -1. So our answer here is -15. Example 6. All right, now here we have a binomial, but with an imaginary number, or imaginary part, adding the same binomial twice. So here, just like if these were a variable, you're going to add real number with real number and imaginary with imaginary. So we have 3 plus 3, which is going to be 6. And then we have -4i plus -4i. So we add them and we get -8i. Right? Same signs, add and keep. And that's it. 6 and the 8 cannot be subtracted because 6 is a real number, or the real part of this complex number. So the -8 is imaginary. So that's as far as we can go. So same thing here, but be careful on number 7 because we have minus versus addition over here in number 6. We didn't have to be too careful. So when you're subtracting, just make sure you distribute that negative inside the parentheses. So that's going to change our signs. So then we're going to have 5 minus 3, which is going to be 2, and then -2 plus 7. Why? Because we had minus a negative, right? That's going to be plus 7. So that's going to be different signs. Subtract them and keep the sign of the larger one. So that's going to give me 5i, right? 7 minus 2 is 5. And then they're both imaginary, so they can combine. So we did real number with real number and imaginary with imaginary, but make sure you distribute that negative first and change the signs. So we work with this one instead of this part, right? Once we distribute the negative. All right, next part. Now here we're multiplying a -2i to the 5, -5, and to the -4i. So we're distributing. So 2 times -5 is going to give me -10, and I, because it's a 2i, we're multiplying in. And then 2 times -4 is going to give me 8, and I times I is going to give me I squared. Now this I squared, we know it can be simplified to a -1, right? I squared is -1. So then this is going to end up being -10i plus 8, because that's a -8 times a -1, so it's going to change to a +8. Now the 8 has to move to the front because that's a real part, and then the imaginary part goes second. So then this is our answer. And example 9 here. So here we're doing FOIL, where we're going to have to do 3 times 3 and then 3 times -4i. So we've done this again with binomials with variables, but now our variable is an I, which is an imaginary number. So 3 times 3 is 9, and then 3 times -4 is going to be -12i. Then we move to the next part. -4 times 3 is going to be -12i, because that's a -4i. And then -4i times -4i is going to give me a positive 16i to the power of 2, or square root. Now the middle two terms are like terms, and they will combine to give me -24i Then we're going to have plus 16i squared. But then that I squared, we know is going to change to a -1, right? I squared is -1. So that's going to change to a -16, right? This is going to give me a -16. So then the 9 and the 16 are like terms, so those are going to combine. And we're going to do 9 minus 16, which is going to be -7. And then minus 24i. And remember, the imaginary number goes second, the real part goes first, or the real number. Example 10. Here we have 3 to the third power. So remember, if you have a number inside, that's going to be raised to the 3. And then the I is going to be also raised to the 3. So those are properties of exponents. You remember that, where everything inside gets the exponent that is raised to outside the parentheses. Well, 3 to the third power, that means we're going to get 3 times 3 times 3. So this is going to be 9. And then times that 3 is going to be 27. I to the third power. Well, you can go back to your notes up there to check what I to the third power is. So let's go back up here, which we can already work through it. I to the third power is -I. So then this is going to be 27 times -I, which in reality is going to be negative. Oof, that looks like, sorry, times, because that looks like we're subtracting. Which in reality is going to be 27 I, -27I. You know what, guys? I'm just going to double check that because I don't know why that threw me off. So I squared, we know that's -1. And then if I multiply times another I, it's going to be times a -1. So it's the same thing as negative of a negative. Yeah, sorry, just need to check myself. So it's the same thing. So just -27I. All right, now we have 2 times 3, so those multiply regular, 6. And I to the 2 times I to the 2, when we multiply variables, we add their exponents. So again, I, just like if it was a regular variable, that's going to be I to the 4th power. So then I'm going to go back up here and see what I to the 4th power is, and that's just a regular 1, right? After we multiply so many times. So then this just equals to 6, because it's going to be 6 times 1. And 6 times 1 is just 6. Okay? So a lot of fun things you can do when you have imaginary numbers. And you just follow all the properties we've learned with multiplying either binomials, FOIL, distributing, and all that fun stuff. If you need help, please ask. I expect a lot of people to be asking for help, okay? Please, please, please ask in class, and I'll be happy to help you.